All right. Thanks everybody for joining. I think most of our registrants are now here. So if you're just joining us, welcome to today's live demo with Logz.io. Just a couple of quick housekeeping items before we begin. So first, just know that this will all be recorded. So if you need to get up for a moment to grab a coffee, you can always come back to where you left off afterwards. And second, feel free to ask any questions in the questions box. I'll leave some time at the end for Q&A. So just a bit about myself. I do product marketing at Logz.io. So I work on positioning, I help prepare sales, and I do events like these to help people envision how they can use Logz.io in their organization. So for those of you who are new to Logz.io, I'll go through a couple of slides to explain a bit about our approach to cloud monitoring and observability before we hop straight into a demo. There are a lot of logging and infrastructure monitoring and security solutions out there, so it's important to know how we're different. So Logz.io is a cloud observability platform, and we provide the best of breed open source tools for log, metric, and tracing analytics all together on one platform. So that's the EOK for log analytics, Grafana for metrics analytics, and tracing for Jaeger for tracing analytics. And these are all delivered on a unified on a single platform, so you don't have to switch between tabs to analyze different kinds of metrics. They're all delivered without the hassle of managing them at scale. So you don't need to worry about cluster management, hosting the infrastructure, sharding. It's all delivered as an auto-scaling service. And they're also delivered, we've also built additional analytical features on top of the open source to reduce mean time to remediation. And I think that's where I'll focus most of the demo today, on the features we've built on top of this open source, just to make it faster, more integrated, and easier to use. All right, so here's the Logz.io Cloud Observability Platform, just from a bird's eye view. It's easier to show this kind of overview in a slide rather than in the demo, but we'll get into the product pretty soon here. So you're starting with your environment, your data over on the left, and you're shipping that data over to the Logz.io managed service, where it's ingested and collected by our unified data store. Now, this service is auto scaling, so you're still using the open source that we just saw, except you're not scaling it yourself. It's a multi-cloud service, so you run on AWS and Azure. There are strong role-based access control measures put in place over the service, and of course, the service itself is secure and compliant with all the industry standards that you'd expect from a company like Logz.io. And so once the data is in the unified data store, it is parsed, it's enriched with security insights, and from here, you can query the data with our product portfolio on the right. So you see infrastructure monitoring, which is where we'll start the demo, which looks at metrics. It's based on Grafana. We have our log management solution, which is based on the ELK stack. Distributed tracing, which is in a private beta right now, so we're not gonna look at it today, but that's based on Jaeger, if you're familiar with the open source tracing world. And then finally, we have a Cloud SIEM that's also based on the ELK stack. So those are the products that we'll look at today, and that's how you're actually analyzing all the data that's collected in the unified data store, which is the data store itself is based on Elasticsearch. So that's just like the basic high-level overview to help you kind of visualize how you'd be sending your data to Logz.io and analyzing it in Logz.io. So after this slide, we'll jump into the demo. But the first question I always get is how to ship data. So I just want to hit this right off the bat. So the answer is with Logz.io, there are multiple different ways that you can ship your own logs, metrics, and traces to Logz.io. So the most popular way is with open source technologies like Beats and FluentD. These are the most popular ways that, like I said, that customers are shipping their data to Logz.io. And that's often because a lot of our customers are already using open source. So this is how they're already shipping data. So they just have to switch the endpoint and it automatically starts showing up in Logz.io. The second way is to ship directly from the cloud. So we've built integrations with AWS, Azure, and Google Cloud to make it easy to collect all the data in these cloud services and then we use some kind of we use a serverless function to ship the data, to forward that data over to Logz.io. It's a pretty popular solution as well. And then thirdly, you can ship your code straight from your code base by installing these libraries, which are readily available into your code base. This is actually how Logz.io ships our application logs over to the platform. All right, so that's enough slides. Let's get into the product. I hope that was a clear enough overview of how Logz.io kind of works and how it differentiates from some of the other observability solutions out there. So this is our infrastructure monitoring product. It was at the top of the list of the product list we saw before, and this is the homepage. So at the top here, you see these different columns have pre-built monitoring dashboards in them. So these are, as you can see, they're based on popular cloud technologies like Kubernetes, different databases, a bunch of different cloud services. So you can, once you ship your data, you can just open up these dashboards and they'll start populating. So just a way to quickly get up and running. As you scroll down here, you can just see some information about the data that you're sending, so you can stay on top of your plan and understand where your data is coming from. So I think that's enough for the homepage. Let's dive into one of these monitoring dashboards so you can kind of see what it looks like. So if you've used Grafana before, this should look very familiar, and that's because this is all based, our infrastructure monitoring solution, like I said earlier, is all based on Grafana, and that's purposeful, right? It's one of the most popular metrics analytics solutions out there. So many engineers are already familiar with how to use it when they get up and running on Logz.io. And so these are all metrics of, these are all typical metrics that someone running a Kubernetes cluster would want to know, like their used memory, the available memory, the file system space. And then down here, we see CPU memory usage and pod network IO. So you can dive into these visualizations just like you would in the open source version of Grafana. So pressing edit there, I can change the query if I want. And we've also built alerts on top of these Grafana visualizations. So this isn't something you'd see in the open source version of Grafana, but we've built something that allows you to drag and drop an alerting threshold over the visualization. So here, obviously, you can see this Nginx container is making this alert fire. It's configured to send it to a Slack channel. And so let's dive into this spike a little bit deeper. So we can see that at the same time, the pod memory and the CPU usage spiked at 2130, right? And so clearly it's this Nginx container that is the culprit. So if we filter it down, we can kind of narrow in on this Nginx pod, and it's pretty clear that there's something going on here, right, that we might want to investigate. So metrics are really helpful for telling us that there's some kind of problem. But now the issue becomes we need to diagnose the problem, right? So the metrics really just show a symptom of what's going on. Now we need more descriptive information to actually troubleshoot and investigate the root cause of the issue. And to do that, we're going to need to look at our logs. And so what we're going to do here is we're going to hit this Explore in Kibana button, which is going to take us to our log management solution. And it's going to show us the logs associated with these metrics so we can better understand what's causing these metrics to spike. So hit Explore in Kibana, and you'll see we're in our metric solution, and it changes over to our Kibana solution. So now we're in log management, and it's showing us all of the logs that are associated with those metrics. And when I say associated, I mean it's the logs coming from the same service or the same pod at the same time. And you can see that this Kibana, that this query was carried over from Grafana. It's a different query because it's in Kibana, not Grafana, but you can see how it shows the same logs that are associated with that pod we were looking at in our metrics. So right away, it's clear that there's a spike, a similar spike in our logs, that we saw a similar thing in our metrics. And it's these Java IO exceptions that we're seeing the spike in these Java IO exceptions. So clearly It's this application exception that's causing the issue to take place. So the alternative, if you didn't have log and metrics on the same platform, you'd have to be doing these queries in different tools, querying different data, in different tabs. And so you can already start to see the value of having multiple data types just consolidated in one platform. It's also less tool sprawl, right? So you can you're having everything in one place, a little more centralized, a little easier. So now that we're in our log management solution, I'll spend some time here showing Kibana, and then also what we've built on top of Kibana. So Kibana is it's the most popular log analytics solution out there. It's open source. It's the K in the ELK stack. So it's what you use to analyze the data that's stored in Elasticsearch. And like I had said earlier, we provide it as a fully managed service. So you don't have to worry about upgrading or worrying about how it's connected to. You don't have to worry about troubleshooting. It's all managed. This is all managed for you, and that's the same. Elasticsearch is included in that. So if you haven't used Kibana before, I'll just show you some of the more basic features. We can add filters here to search for different data. So I'll just look for our error logs. Adding this filter here will bring up all of our error logs. You can also visualize this data. Kibana has some really powerful visualization capabilities. I'm opening up this Apache Access dashboard, and you can see all the different ways that you can visualize log data. You can see a time graph up here to show that which breaks down our Apache logs. You can see the different browsers here in this donut graph. We have a heat map here and a geolocation map down here. A whole bunch of different ways to slice and dice your data with Kibana. And this is something you would receive with open source Kibana too. It's something that a lot of engineers know how to use, and it's a really powerful tool. So now I'll show you some of the features that we've built on top of Kibana. So get over to this Discover tab. Just one moment here. Sorry about this, folks. I think we all have encountered some Wi-Fi issues at one point. I'll just reopen Logz.io, and then I'll show you some of the features that we've built on top of Kibana to make it a little faster and easier to use. All right. So if you've used Kibana before, yeah, like we covered, this should look familiar. What I'm going to show you first is in terms of what we've built on top of Kibana is what we've built on top of it. So I'm going to change our time filter here to make this the last 15 days. So this is going to show us all the log data currently in our indices. So you can see we're starting with almost 15 million logs here. So if I'm searching for specific log data in this list, obviously that's impossible. What I can do is start to query my data to start to figure out and identify specific log types that I might be looking for. But even that requires time and some expertise of how your logs are parsed. So what I can do instead is just hit patterns. And what that does, it's something we've built on top of Kibana. It uses machine learning to cluster similar logs into smaller, more manageable groups. So instead of having these proxy request logs, dispersed throughout all these other logs, they're instead clustered together, and we can see that 17% of our logs are these proxy request logs. And as I scroll down, I can quickly understand all the different kind of log messages that are being generated by my environment. And so as I'm looking for specific log data, I can filter out these patterns. What I'm doing is really reducing the haystack, if you will. If you're finding the needle in the haystack, reducing all of this log data from just reducing the noise, really, so that I can more easily find the data that I'm looking for. So just with those 4 clicks, I filtered out, probably almost half of my log data. And so oftentimes, the logs that are really worthy of attention aren't, are coming in smaller batches. So I'm going to reverse the count here. And already I can see, so these are my smaller patterns. Already I can see this SSL library error. Obviously something worthy of my attention, right? That's something that would have been impossible to find in this group of, almost 15 million logs. It says 9 million now because I filtered out these ones. But unless you know exactly what to look for, this kind of error would be just impossible to find. So that's the power of kind of grouping your logs into smaller groups, so that instead of looking at millions of records, you're looking at tens of records. So if I filter this in, now it's just going to show me my SSL error logs in just a moment. There we go. You can open it up and start to explore more about the, start to learn more about the error. So I'm going to show one more way that I could have found this SSL library error. I will clear all my filters here. So that again, we're starting with almost 15 million logs. So another way to find the needle in the haystack, because that's a big part of logging, which can be hard, is with cognitive insights. So that's something we've built on top of Kibana as well. And so what I'm going to do is I'm just going to open up the insight, and then I'll explain how we got there. So that SSL error was a certificate problem. So I'm going to open up the certificate insight here, and that's going to bring us the same SSL library error we were just looking at. And so I'm going to open it up and explain how Cognitive Insights was able to do that. So we open up the log and we see that there's an Insights tab. So what Cognitive Insights does is it cross-references all of your log data with internet data on, including these forums such as Stack Overflow, GitHub, Bugzilla, and it's able to identify the logs indicative of a problem based on the collective experience of engineers discussing these problems on these forums. And so what it's able to do is find known issues in your log data that would be really hard to have found otherwise. And it really is that's probably the best example of finding the needle in the haystack, because it would be impossible to find some of this stuff unless you knew exactly what to look for, which oftentimes you don't know exactly what to look for. And so we can see other examples of this. I'll clear the SSL error, and I'll open up another insight here in just a moment once my Wi-Fi starts to cooperate. There it goes. So maybe I just reconfigured a SQL database, and this insight pops up. I can click it, and once it loads, I'll be able to see this Sql syntax error. So we can see these new logs pop up. I'll open it up. Again, opening up the Insights tab. And we can see this SQL syntax error. So that's another example of how Logz.io is able to quickly find the needle in the haystack, so you can find what you find. So now that we covered, those are some of the main features I wanted to show that we've built on top of Kibana. There's plenty more that we could show here, but in the interest of time, I'm going to move on. So the next thing I'll show, the next product I want to show is our Cloud SIEM offering. And so I'm gonna navigate to that by going to this security tab up here. And you're going to see that it looks pretty similar to Kibana, and that's because it is. The whole product is also built on ELK, so that DevOps teams responsible for security can use the same interface that they already know to query and analyze threats, just like they would their just like they would, troubleshooting production. So you can see similar Kibana visualizations that we saw in that Apache Access dashboard, just tailored to be a fully functional, fully instrumented SIEM. So we can see different access events, threat events, audit events, endpoint events, and it's all broken down. All these events are broken down in different ways depending on how we want to investigate the data. So let's do like a mock. We'll do a mock attack here, and I'll show you how to investigate different threats that Cloud SIEM is able to detect. So let's just look for the worst one here. This AWS EC2 log showing brute force login attempts looks pretty bad. It's severe. So what I'm going to do is I'm going to begin to research this. So I'm going to go to the research tab up here, and we saw it was AWS EC2. So I'm going to search for that dashboard. Open up EC2 Instances Overview, and this shows us all of the security events related to our EC2 instances. And so what's immediately clear is that Dana, this user, is showing some suspicious activity. It looks like Dana has started over half of the EC2 instances over the last couple hours, and has in fact done so successfully. So what we're going to do is we're going to click on Dana down here, which is the user, and this is going to show us all of the logs associated with all of the logs showing Dana's activity. And so it's immediately clear that around this time, Dana was up to no good. We see that Dana has visited some URLs associated with malicious addresses, some mining related, some phishing related. Dana has also triggered security rules based on Zeek, an open source security tool based on AWS CloudTrail, Suricata, and then this audit log. So it's very clear that Dana is conducting an attack, and that we can and now we know to respond appropriately. So I'll just dig a bit into these alerts. So these alerts are based on rules and these rules are based on all these different cloud technologies and security technologies that are common in many DevOps environments. So these rules are based on so examples are AWS CloudTrail, like we saw, integrations with HashiCorp, Palo Alto Networks. If you're interested whether Logz.io has an integration with the security tools you're using, feel free to check out our website. It'll show you some of the integrations we have. And then in addition to these rules, which identifies malicious activity, we'll have the integrations will include a dashboard like this EC2 dashboard to investigate the activity associated with that technology. So the last thing I want to show in the Cloud SIEM product is our threats overview dashboard. So all of your logs are being with Cloud SIEM. It'll cross-reference all of your logs with threat feeds, and it's able to identify malicious IP addresses, malicious DNS information in your logs to just highlight the activity that can be considered malicious. And so again, I can drill into these. I can drill into these attacks by clicking on the attacker IP, which will show me the logs associated with that malicious activity, so I can learn more about it. So those are the key parts I wanted to cover today. I intentionally kept it under a half hour just to show a brief glimpse of what Logz.io can do and how we differentiate from open source Kibana, open source Grafana, and also I always like demoing the Cloud SIEM as well. So I wanted to leave some time to go over questions. I see we have a few, so I'll open them up, and I'll I got some warnings that my battery is going to die. I appreciate those warnings. I also have some questions about the product, which I'll get to. I just need to decipher them. So if you have any more questions, feel free to ask them now, and I can address. So one question I found is about filtering out log data, and that's a really good question, because it's something that comes up a lot, especially as folks are trying to reduce their logging costs, right? So Logz.io is not unique in that the costs are we charge based on the volume of logs being indexed in Logz.io's managed service. And so what you can do, if you want, is filter out some of your noisy logs that you may not want to look at. You can filter those out before they're indexed. So that way you're not being charged for logs that you don't actually want to monitor. So I'll show an example. So let me change this query again so I can find some more of our data. All right, almost 15 million logs here, like we saw last time. So again, it can be hard to figure out what our noisiest logs are just by scrolling through it. So this is where patterns can also be helpful. It can be really helpful for data management. So you have to be careful when you're using patterns to filter out data, because we filter out based on log message. So if I were to use this, the filter would not work, because this number is a variable. It's not part of the string itself. Same with this value, all the orange text. But this proxy request log, that is not that is just a message, right? So if I filter this in, I can see the proxy request. I can see the proxy request logs as a message here. So I'm going to copy this message, and we're going to filter out these proxy request logs. Navigate to our job filter tool here, add a job filter. Oh, I'm using too many, so I'm going to delete one. There we go. So this is going to look at, this job filter is going to look at service 10, because I know that's where that job filter log came from. And I'll look at the message field. And I'll paste the log message right here. I'm going to click this box and apply the filter. So what this is going to do is, from now on, all of the proxy request logs will be filtered out. That way they won't be indexed, and they won't be held against my my Logz.io costs. I can always deactivate the filters right here to begin ingesting them, to begin indexing that log data again. And just I'll move on to the next question soon, but I also want to point out that you can also archive all of your data. So that way you can still access any data you filtered out, but you have to begin archiving before you begin filtering out the data, so that because the last thing you want to do is be flying blind during a production incident and not have the log data that you need to troubleshoot an issue. So that's why we provide this offering, so that you can always maintain access to all of your log data without needing to index and pay for everything with the Logz.io license. Next question I see. Let me, I'm sorry, I have to read the questions before I answer them, and so it's hard to decipher some of them. All right, which threat feeds are used? So I'll go back to our Cloud SIEM product. So it's mainly public feeds right now. We're working on incorporating some private feeds. Threat intelligence feeds. So in this instance, we have 12 feeds that are cross-referenced against all of our log data. And so yeah, you can read through them here. If you want to get a better, if you want to dig into this list a bit more and ask more questions about the kind of feeds we use, I would feel free to reach out through our through our website. All right, next question. How do I collect Windows events from thousands of machines, and how do I manage the agents that collect the logs? Yeah, so that's a great question. So I think the best way to answer that is to go back to this slide back here. Well, no, actually, let me go to our data shipping tab. I'll scroll down to Windows. So these are instructions on how to send your Windows tabs. Again, if you want to learn more about it, I would reach out through our website to see how it would actually work for you. Depending on whether you're using AWS or Azure, a lot of our folks who are shipping their logs at large scales are doing so through our cloud integration. So all of your Windows logs would be shipped to a cloud service and then forwarded over to Logz.io. I hope that answered the question. Just reading through some of the questions here. There's a question about network traffic, and that can definitely be monitored with Logz.io. So I'll go back to our infrastructure monitoring product here. I'll go back to this Kubernetes cluster. So we can monitor. There actually isn't great data in this demo account to see how to monitor network traffic, but you can see pod network IO metrics being monitored here. And you can set up more network. If you're we're just not shipping a ton of network traffic data to this demo account, but you can certainly configure, set up data shipping to send those metrics and logs over. All right, I'm back, everyone. I'm sorry for that. I'm sorry for that problem I had. Wi-Fi went out at a really bad time, but I am back, and I do have I do have a few more questions that I can answer. So again, I'm sorry about that. If you have any more questions, feel free to put them in the questions box so I can address them. So I just want to finish my point about the difference between archiving and indexing your log data. So we archive our log data so that we don't need to index everything in Logz.io, because indexing everything can get expensive if you're shipping a huge amount of log data. Our license is against the amount of data you index. So if you archive it instead, you can still access any data you filtered out, so that you're not flying blind during a production incident. And so the retention in Logz.io is totally separate from how long your data is archived in S3. However long you want to archive your data in S3 is totally up to you. But and it's up to you with Logz.io as well, but you don't need to set them as the same retention. So the retention in Logz.io can be 3 days, but the retention in your S3 bucket can be, 2 weeks. It's up to you. So you can see how there's a difference between how long you want to keep your logs indexed in Logz.io and how long you want to archive your log data. All right, the next question is, what is the minimal network bandwidth required by Logz.io to pull infrastructure data? Yeah, I think that's a question that would be better off answered through probably a sales engineer. I'm not entirely sure what the network bandwidth would be. It might depend on it probably depends on your data and your environment. All right, and looks like that's all the questions that I received today. So unless you have any more questions, thank you so much for attending today's live demo, and this live demo will be recorded, and my email will be in that recording. So if you have any follow-up questions, make sure to email me. It's no worries at all. It's charlie.klein@logz.io. Again, my email will be in the recording. So thanks to everybody so much for tuning in. Make sure to email me with any questions, and I'll look out for an email from Logz.io with a recording of the demo. Thanks again, everyone, and take care.